me start with the slideshow. Okay, hello everybody, and I want to talk about something new. Something that's still in development. It's to run Dapr Microservices in WebAssembly. Now you must think, why? Why on earth would I do that? Isn't that something in the browser? So let's start with state of the art. How do you do? As a beginner, how do you do a web service in a microservice in a Dapr environment? So you write your microservice in your favorite programming language. It could be Java, Rust, Go, whatever. And then there's numerous Dapr API SDKs. You can integrate those language applications and then access your sidecar services. Then you build your microservice by either compiling it. If you are Go or Rust, you compile it. Or if you have a higher level language, you run it in a language runtime. Say it's JavaScript or Node.js or Ruby, Python, or whatever. Then comes to the important point where you deploy it. You typically deploy the microservice and its runtime in a container, and then the Dapr sidecar in another container, right? So they form a Kubernetes pod, and it's all very nice. So that's how it's done today. And what's not to like? I think the thing that's mostly, because we do WebAssembly, so the thing that has caused most friction is the Linux container here, especially if you have a lot of cases where you have to deploy on the edge, where the computing resources is limited, and the Linux container often drags in the Linux operating system, so it's heavyweight. It is hundreds of megabytes, and oftentimes 100 megabytes. And it's slow at startup. That's a common issue with essentially all container-based applications. If you look at AWS Lambda, the number one people complain about is the cold start, right? So the cold start could take measured in seconds. And so the solution for that oftentimes is to keep warm. I have the service started and not shut it down. That's start and have it running all the time. However, when you have an environment which has a lot of services, the keep warm with a heavyweight container consumes a lot of computing resources. So that's the second issue. And the third issue, of course, is in general, I think there are safety issues with containers that has become more and more apparent. So not only there are container escape, you need tools like gvisor and things like that in order to make it more secure. But the container runs a fully fledged operating system. It has a large and complex attack surface that that if you expose it to the network, it could have a lot of problems. And then, container management is another issue. You could have, that's essentially one of the hot topics today. It's the software supply chain issues because you get so much dependency in your tree that that people no longer keep track of what's going on, right? And another issue is that, especially on the edge platform, is that containers are not really portable across CPUs. So you need an ARM version, you need a RISC-V version, you need so those are the issues. So that brings us to WebAssembly, which essentially is the answer to all the issues that I have just mentioned. So WebAssembly has an unfortunate, I think the name is a misnomer. It's not. Today we are using it not on the web and not as assembly language, right? So this is not web, not assembly. And so, however, what do we call it? It's an opinionated runtime, optimized for microservices. Why do we say that? It's not a general runtime. So we're going to talk about that in a minute. However, compared with a Linux container image, it's often 1/100th of the size. So the Linux, say if you want to do machine learning or AI inference, things like that, the Linux container can often go to 10 gigabytes, and a WebAssembly application could be in tens of megabytes, right? The startup time, instead of seconds, it would be measured to be under 1 millisecond. So you can truly have microservices that start up at demand. So it's have near native performance, because there's a technique that we can not just to do JIT, but do AOT, pre-compile WebAssembly bytecode into native code and run them there. And then it's secure by default, and so because it doesn't have the operating system and all the features in the operating system, it's completely portable. And the last thing is important: it plays well with Kubernetes service mesh and distributed runtime, etc. So that's what we want to focus on in this talk. So, of course, when I show that slide, people always say, it's too good. There's no free lunch in the world. If it's so good, then, what's the catch? But of course, there's a catch. It's not a general OS operating system environment. That's why we call it an opinionated approach, right? So it needs its own language SDKs. It needs its own, libraries. A lot of the libraries that you commonly use need to port it to WebAssembly. However, why I think Dapr is a good audience here is because I think Dapr also is an opinionated approach, right? Is that you need to buy into this programming paradigm and to get the benefit to learn this to learn this new way of programming. So the project I'm at is called WasmEdge. Is a WebAssembly runtime under CNCF, and it's called WasmEdge. Wasm is short for WebAssembly, and Edge is for what we consider edge computing. So it's a lightweight WebAssembly runtime that's specifically designed for running on the server. So it's high performance, extensible. So it has some nice features which I'm going to show in the demo in a minute. So, and one of the other interesting thing that we have just announced yesterday, and Solomon Hykes tweeted today, is that Docker itself has launched support for WebAssembly tooling through with integration with WasmEdge. So so there's a GitHub repository there. It contains a fully database-driven microservice. So it's a microservice running inside the WebAssembly sandbox with a MySQL server running inside a Linux container. And it's all started up by a Docker compose command. And then you can interact with that microservice to read, write, update into the database. So it's, if you have time, I encourage you to check it out. It literally takes only one line of code to start, one line of command to start it up. It's a Docker compose up. So what is the new approach that we want to propose, with WebAssembly and the Dapr and the container that work together, right? So, what we want is to create microservices using standard libraries. We don't want to, although the application may need to be rewritten, may need to be using a new SDK, however, we don't want people to learn an entirely new way to write their services, to start a web server and, things like that. So create microservices using standard libraries, specifically in Rust. We want people to be able to use libraries like Tokyo, like Hyper, like MySQL async, and things like that. In JavaScript, we want people to just use Node.js. And the reason they can use Node.js in WebAssembly is because we have ported the JavaScript runtime and much of the Node.js API libraries into WebAssembly. And then compile the whole thing into WebAssembly and use WasmEdge to run the microservice, use WasmEdge as a sandbox instead of use Linux container. So, but that leaves a big question. What about the Dapper SDK? So in this new setup, we created I think an experimental version of the Dapper SDK, which it's interesting to hear the talk from the previous speaker. He did the HTTP version of the Dapper SDK. We did that too because that's easier to manipulate. So it's implemented using the Rust request library, and it's intentionally misspelled because the request is a keyword, the language keyword, right? So it's I don't know how to pronounce it, but request. So it's an async HTTP library that connects to the Dapr HTTP API. So the application would look like this. So the sidecar still lives in a container, and then the web service or the microservice or the application itself runs in a WebAssembly runtime to take advantage of the benefits that I have just mentioned, right? The speed, the lightweight, the cross-platform compatibility, the security, and all that. So the application logic could be written in, say, JavaScript or Rust, and it starts an HTTP server to listen for incoming HTTP requests. Actually, I think that incoming HTTP request should also come from the Dapr sidecar, as a service invocation, instead of being opposed to the internet directly. So it's I need to redraw this, but but the business logic function talks to the Dapr sidecar through the what we call Dapr SDK WASI. So it's a WebAssembly version of the Dapr SDK implemented using Rust. So here is a demo application, and here's a GitHub URL. So what we have done is that we created 3 microservices, and each with a Dapr sidecar attached to it. And one of them also has a MySQL database attached to it. So if you guys are familiar with the new web paradigm, it's a Jamstack. So that's so the web page becomes a static web page, and then can deploy it on, say, GitHub pages or even on a blockchain, whatever you want it. And it's used JavaScript to talk to the Dapr sidecar and use the invoke, because Dapr sidecar already have cores. So it can also configure to use HTTPS. So it does all this, for us. And so it comes into Dapr sidecar and asks for which service it needs to use. So the Dapr sidecar communicates among themselves, discover the service, and then invoke the service, and then have the data come back, and then goes back, right? So each of those sidecars use some Dapr services. The top 2 are image manipulation services. So they use service invocation and state management. And the last one, because it has database credentials, so it also uses a secret service. So let me go through the code really quick. So this is one of the image classification examples. So what it does is that it's a WebAssembly application. So on the left panel is how do you start a server. So if you are familiar with how to use Rust to start a web server, that's exactly how people would do. There's no change. That's exact same code. So you start a server, and the server, you have a handler function. Whenever a request comes in, it's non-blocking, so you can handle multiple concurrent requests. When the request comes in, it calls a function called classify and pass the request in it. And in that classify, there's maybe a screen of code that I don't show here, but you can go to the GitHub repository and look at it. Is that essentially what it's load a TensorFlow model and then runs the AI inference on it to figure out what's in the image, right? So that's I want to show you a complete example that you can do AI inference and all that in Rust and compile into WebAssembly. However, the important piece of Dapr-related piece of code is on the right panel. So using the SDK I've just mentioned, so we created a connection to the Dapr sidecar that is local to this service, right? And we use that to invoke the event service. If you remember that event service is the one that connects to the MySQL database. So we use it as logging, right? So it's for demonstration purposes. And then we log the key value, the IP address of the incoming request and the value. So the idea here really is that we can maybe sometime in the future we can rate limit that, or or have some kind of IP gates that's to manage how the service is being consumed. So in the event service, on the left-hand side, it's also to start the web server. However, it's also start a database connection pool to the MySQL. So it's have 10 connections in the pool. They're all asynchronous. That's the application would be able to use. And how it starts the database connection pool, it's use secrets that's stored in the Dapr sidecar, right? So it has a database username and password. Here we just get the complete connection URL and starts that. And so it's the same thing. If you remember the last slide, we invoke this service and call the create event method on it, right? So here is the create event method that's in the event handler of this web server. What it does is that it's execute a SQL statement and send the data into the SQL database. So I want to show you what's the complete demo look like, just to prove to you it actually works. So let me see. Yeah. So here is a static website. The website can be, like I said, the website can be hosted anywhere. It can be on GitHub pages. So I select a photo. Okay. So let's say this one. So we have 2 services. One, 2 microservices, each has a Dapr sidecar attached to it, right? One of them is called Grayscale. So what it does, it do image manipulation. So if I say submit, it turns the image into grayscale and come back. Nothing fancy. You get, instead of 1 crop, you get 2 crops. And but the other one is more interesting. It's classify. It uses a pre-trained TensorFlow model to try to recognize. It's a mobile eye model to recognize what's in the image, right? If you say submit, what it does, you see, it returns almost instantaneously. Because running TensorFlow in WebAssembly is the same as running TensorFlow natively. So what it, I always thought this image is an icon of the Rust programming language, but it says it's a crap. But so that's and on the back end, both events is logged into the MySQL database. So that's I would say a complete application. Although it's not that useful, but it's a complete application that is written in in Dapr. So let me continue from here. I think I'm almost done. Okay, so the reason I want to come here to talk to you guys is because we need help, right? We are open source project, and I think it's take a community to build something like that. We'd love to. We implemented part of the Dapper SDK for WebAssembly. That's there are things that we haven't implemented. For instance, the pub sub, those the more complex services. We love to get community's help, to help us implement that either in Rust and also in JavaScript using the fetch API that we have supported in JavaScript. And the other thing, maybe perhaps even more interesting, is it possible to port the Dapper sidecar itself to WebAssembly, so that runs in WebAssembly as well, instead in a Linux container. So that'll be the end of my talk. Thank you very much.
Are there any questions?
Not a lot. It's a lot of this is to make WebAssembly work with networking and that sort of thing. But I think what I really like Dapper is the documentation is pretty clear. So if I just look at an example how the HTTP interface works, of course, I think a gRPC is more complex, so that's why we choose HTTP, right? That's yeah. I think we have I worked on it. One of my other guys working on it. It's a couple I think a couple weeks of part-time work. Yeah.
Okay, so great presentation, by the way. What would you use on the Dapr sidecar once it's ported to WebAssembly? What would change in your architecture?
Yeah, I think one of the issues is that Go language support in WebAssembly is still left a lot to be desired, because Go needs a garbage collection and runtime for that. So to compile regular Go application into a WebAssembly, I think it's still challenging. However, I think we are getting there because the community work on that. However, TinyGo works, but I don't think Dapr works with TinyGo. That's so it's. So I think so I put that maybe because I think that's more work. So this may need a substantial amount of rewrite, or to have a lighter version of that, or something like that. Yeah. So I haven't really looked into exactly how much work it's going to be, but I know it would be substantial, I think.
What would you use for if once the sidecar is
Okay.
Assuming that happens.
Right. So I think that because the vision is always you have WebAssembly sandbox and Linux container running side by side in the same cluster, and the Linux container running the heavyweight long running work, and the sidecar running the lightweight and temporary work. I think because a lot of use cases I see in Dapr today is on the edge. So when you go outside of the big data center, on the edge data center and on 5G network and things like that, I think to have the sidecar itself in WebAssembly would dramatically reduce the whole system's footprint, and perhaps make it faster. That's yeah.
I think you're hinting at one of my questions there. On the edge there, do you have any particular scenarios of where you're going to use WebAssembly and what it means and where Dapr would fit into that?
Yeah, so I think on the edge, there's the edge network is defined very broadly. It's from the CDN network, that we see today, all the way to the, if you look at the 5G network, there's a lot of, in base stations, the MECs, and, there's a lot of network like that. So ideally, there should be opportunities to deploy applications in there to be closer to the, say, the IoT devices and, your data sources, right? So to have the, to have the application developed and deployed at that level, I think it requires a lighter weight, although, container-based solution would work, actually, is how people use it today. But I think to have a lighter weight solution and perhaps faster solution, and to have to increase the computing density, I think would generate cost savings and improve efficiency in that world. Yeah.
Okay, so we're done with questions for now. I want to give you guys a chance to go eat so you don't pass out. But thank you again, Michael. This was a really great talk. One more round of applause, please.
Thank you.